So for this one, I was trying to verify that all of these points are going to equal this 0 with the z. And what I ended up concluding is that all of these points are going to have this, this, and this relationship, regardless of what A, X, E, Y, F, B, C are. This down here is always going to be equal to 1. Did that nice little math. And then for part B, so I found this point here, matched it up with that, found this point here, matched it up with that, this point, that, this point, that, and then I set my transformations here. My point here, that's because it's the transformation that is equal to our new point, which I wrote there. I solved for that, and then I found my transformation here for B. Just some verification that it works. Same thing where I found the different points on the guy, and then I looked at how he moved. Lots and lots of solving, lots and lots of variables. I ended up having to do some thinking. So with this C value is equal to 0, this came from the fact that I would want my leading coefficient here, and at worst here. I would never want my leading coefficient here. So then with that logic, C would have to be 0. And then I verified this as well with using my computer to do the transformation thingy online, and that ended up to be true. So then I ended up with that. This one took me forever. This single problem took me about 3 hours. This problem was awful because I couldn't understand that it was going in a circle. I don't know what was wrong with me, but I could not understand that for the life of me. Anyway, once I finally figured out this was going in a circle, and wasn't like going by one angle and then getting enlarged, it was awful. It was awful. You don't even want to see what I was trying to do. It was embarrassing. It was downright embarrassing. Anyway, I created this little nice circle, and then I did this, and then I solved for my B value to get my coordinates for right here for that little point, because I wanted to keep it the same as the unit circle. So I got that little point, and then I set it over here. I found this in our notes for this angle stuff. So then I was like, okay, well, my Z value here is I'm not gonna want my Z value to affect my X and my Y at all throughout this. So I was like, okay, I'm gonna just place my Z values at 0. And I'm gonna do that because I don't want these getting affected, because these are oscillating. And if I was to add a Z, it wouldn't necessarily be that perfect oscillation, and then it would ruin my circle. And I like my circles because the circles were a lot easier than what I was trying to do. But anyway, just make those all equal to each other. Like boo, do, solve, view, these radians, great. Let's check my answer. So then I took the 3 and I transformed it into the 4 to see if that would work, just to double check my answer to make sure that that was actually, because that was my guesstimate, where I concluded it logically instead of doing algebra. So then I did my little check, and I got all good, because these were my expected values of X and Y, and I got these, and that's the same. So all good, smiley faces, I'm happy. This is the matrix, and then if you were to go from 1 to 2, and then want to go from 1 directly to 3, what you would do is you would take this matrix and times it by itself. So what I would do, is I would transform it itself. So I would go boop. The question wasn't very clear, so I decided I just didn't want to simplify it. But if I wanted to go from 1 directly to 3, I would just solve this. And then if I wanted to go from 1 to 4, I would just add another 1, and it would get really messy. And genuinely, I was just being lazy at this point because I was so done with this problem. It was awful. This problem was awful. And then I got these little guys, these dancing guys. He moves down 1. This moves down 1. So these two transformations are the same that are happening from 1 to 2 and 2 to 3. So I concluded that here. And here I got that and that and all of that algebra stuff that I did. And then going from the 1 to 2, and then the 2 to 3, this would be your directly from 1 to 3 transformation. And then from here, I'm taking this down here because it's always your transformation, and then your original is equal to your new one. So that's what I did. I put that there, my transformation here, and then my new transformation there. Not gonna lie, this was kind of guessing and checking. I'm hoping this is right. I think I got the right idea for that, I hope. Sorry, here on my computer. Anyway, yeah. And then this is the algebra stuff I did for getting 3 to 4. Yeah. And then from F, I found these little points, and I did the thingy where I graphed them out and figured out how far they went. Found my new ones. This is from 1 to 2, and then 2 to 3, I found this one, and then 3 to 4 is actually the same transformation. If you look at this, it's a 1, 2, nothing changes in this direction, nothing changes in this direction. They don't change anything besides this Y. And I found this because I am a expert at finding Waldo as a kid. I loved those books. It was like reading, but I didn't actually have to read. I was a champion at those books. So then what I did is I took this vector here, and I had this be my, and then that's my transformation, because I'm transforming that into that, and then I get this, and then I take this new one. This is the one that's being transformed by this one, which we found up here, gets this one. So this right here is your 1 to 4, and this right here is your 1, 2, 3, which I wrote like that just for my own, like when I was graphing that out. So this is my guy, and he's gonna fall. He's falling, and he's falling, and then he falls through the floor, and that's where he lays now. That's where he lives now. I found out my 1 to 2 by graphing out the little points. I did 2 points for that one. And then I found my 2 to 3 by graphing new points. And then my 3 to 4 by all of this fun stuff. I concluded this was 1 due to this here and this here, these having the same starting positions and ending positions, because like, although this was, like, the rest of it is affected, this down here is not affected, and these are just the x coordinates, nothing more than that, here and here. Like, they don't have a y component to them. So then I ended up thinking that since this here is, this here would be by the second vector, it would be manipulated by the y. Since these here don't have that y component to them, there must be something that's keeping it there. So I decided to put that 1 there, and it ended up working out. My 1 to 2 there, my 2 to 3 there, get this, and then from this, transform it by this one, get this one, and now I have my, from my first position all the way to my 4th position.